Here, number 15, 3 people are selected from a group of 7 men and 5 women. That gives us a total of 12 people. I think my recording paused on accident here, Tyler, so let me explain that again. The chance that the first person you select is a man is 7 out of 12 because of the fact that there are 7 men out of a total of 12 people altogether. You're not going to put that man back when you pick him, so now there are only 6 men remaining out of a total of 11 people altogether because you took 1 man out. And same thinking with the third person, there are now only 5 men left in the group out of a total of only 10 people left in the group. So when you want the probability that the first is a man and the second is a man and the third is a man, what you do in that situation is you multiply those probabilities together. So I took all the numerators and multiplied them to get 210. I took all the denominators and multiplied them to get 1,320. So the probability that all 3 are men would be 210 out of 1320. Sorry, I said 320. And if you change that to a percent by dividing numerator by denominator, it's about 15.9%. Now, B is a little more complicated because in B, you got to think about the different possibilities that we have here. 2 women and 1 man. Well, you could have the first 2 be women and the last one selected be a man, or first be a woman, second be a man, and third be a woman, and so on. So there are 3 different combinations of 2 women with 1 man. We're going to find each probability. So first combination. Probability that the first one is a woman would be 5 out of 12. Probability now that the second is a woman, there are only 4 women remaining out of a total of 11 people in the group. And then the probability that the third is a man, all 7 men are still present, but there are only 10 people left in the group. So we'll find the probability of woman and man in that order by multiplying those together. Same thing will be done with the second combination. Probability that the first is a woman is 5/12. Now there are only 11 people in the group, and we want the second to be a man. All 7 men are still present. Now there are only 10 people left in the group, and we want the third person to be a woman. Keep in mind we already picked 1 woman, so there are only 4 women left in the group. And again, we'll have to multiply those probabilities to get the second combination probability. For the third, probability that the first is a man would be 7 out of 12. Now there are only 11 people left in the group, 5 of which are women because we haven't picked a woman yet, so the probability that the second is a woman is 5/11. And now only 10 people left in the group. I picked 1 woman, so there are only 4 women left. So again, I'll need to multiply those probabilities together. Now notice that when I calculate all 3 of those combinations, the probabilities are all the same. So there was a faster way for us to compute that. We could have figured out any one of those combination probabilities, which is 140 out of 1320, and then multiply that answer by 3 to get the probability of all 3 of the combinations. Or in this case, I can just add those together because I want either the first combination or the second combination or the third combination. And with or, we add. So 140 over 1320 added 3 times, or multiplied by 3 would be equal to 420 out of 1320, which could of course be changed to a decimal or percent.